Welcome. Continue the study of the rules of differentiation. We'll see today the chain rule. So why do we need a chain rule and what is a chain rule? So sometimes, as we know, the definition of a function is the relationship between two variables. One is dependent and another one is independent. So usually we say y is equal to f of x. What it says basically is that any change of x will affect y. So x is independent and y is dependent because it depends on x. So easily we find the derivative of this kind of functions as we've been finding thus far. But sometimes our y, which is a function of x, is also inside some other function, the bigger function, in which we have a situation like this. For example, z is equal to u of y of x represents a composite function. So what it basically means is that we have some function u, a bigger function, which depends on y, which is another function that depends on x. So what happens sometimes is that we have to find the derivative of this bigger function with respect to that independent variable. So we want to find the derivative of u with respect to x. But u is not directly related to x, u is directly related to y. But what we want to find is the u related to x. What is the rate of change of u with respect to x? So to find this, we use this formula. Du by dx is equal to du by dy into dy by dx. What it says basically is the derivative of the outer function multiplied by the derivative of the inner function. So how? Look at this example. We know how to solve 3x squared plus 6x. This is a way to solve, and we find this using the power rule. But the problem now is that this is inside something. This is inside some power 5. So this is our inner function and the whole function with the power 5 is our outer function. Using the other rules that we have been finding thus far, we cannot solve this. We can only solve what is inside. And if you have another complicated situation in which we're using trigonometric functions, you have tangent, which is a trigonometric function, of secant, which is another trigonometric function of x. So we want to find the derivative of a function of a function. This is the inner function and this is the outer function. So how do we do it? And in this other case, we have 6x, which is a function which is inside another function, which is sine, which is inside another function, which is the sine cube of all that. So these are some kind of situations in which we use a chain rule. And let us see an example. You have 2x squared plus 6x raised to 5. So if you want to find the derivative of this, what you do is find the derivative of the whole function and then multiply it by the derivative of whatever is inside the function, which is the inner function. So this is the inner function and this is the outer function. So in order to help us to solve in case we see these kind of things, it's always good to replace the inner function with something like, for example, let us say u. We can call it as u. And if you call this as u, you can also call it as y in case we're not using y. Then it will help us to realize which kind of situation we're facing. So if in this case I take, for example, f of x is equal to, I replace the inner function by y, so I can write somewhere y is equal to 2x squared plus 6x. So I can write y raised to 5. And from the moment I do that, I can easily figure out that this is a case of the power rule, in which we have a function which is raised to some n, which we saw in one of our videos. So it was x raised to n, and what we did to find the derivative of that was n x raised to n minus 1. So this shows us that this kind of derivative is of the power nature. So how do we solve this? F dash of x is equal to derivative of the outer function. Outer function has power 5, which means our n is 5 using this power rule. So what we do is 5 into the original function, 2x squared plus 6x raised to 4, because we've used the power rule. And now we have to multiply this by the derivative of the inner function. So this is multiplied by derivative of this. You can write here y dash is equal to 6x plus 6, derivative of this. So into 6x plus 6. So derivative of the outer function into derivative of the inner function. So this is 5 3x squared plus 6x raised to 4 into 6x plus 6, and it's done. Now in this function, the argument of our trigonometric function is another trigonometric function. So how do we find the derivative? Again, this is our outer function and this is our inner function because it's the argument of some other function. So to find the derivative of that, we have to remember the derivative of tangent and derivative of secant. So derivative, if you say y is equal to tan of x, and you can say g of x is equal to sec of x, we know that the derivative of tan of x is secant square of x, and the derivative of g of sec of x is sec of x into tan of x. So to find this, what you do is the derivative of the outer function multiplied by the derivative of the inner function. So what we'll have is f dash of x, which is our function, equals to derivative of the outer function sec square of x, which is the derivative of the tangent. In this case now, the difference is that the argument is not x. The argument of this tangent is secant of x. So we have secant square of x of secant of x, which is the argument we have in this function. So derivative of the outer function multiplied by the derivative of the inner function. So in the inner function, know that is secant of x into tan of x. Indeed, the argument of this secant is x, so it becomes secant of x into tan of x. So in short, what has happened is that f dash of x was equal to derivative of tan of sec of x. So we kept the argument, which was sec of x, and then we found the derivative of the outer function, which was tangent of x, and it gave us sec square of that argument that we did not touch, multiplied by the derivative of the argument, which is sec of x into tan of x. So now we have here another case. A function inside a function inside a bigger function. Our first function is 6x, our second function is sine, and our third function is sine cube of 6x. So how do we find this? We'll have f dash of x is equal to, our outer function is this function, and then we have some intermediate function called intermediate function, and we have here the innermost function. You can call it as innermost function. So basically have three functions. So how do we solve this? Starting from the outer function. The outer function is a function sine cube is the function of with the power 3. So the derivative of that function is, using the power rule, we take the 3 and pull down. So we have 3 sine square of 6x, this is the derivative of the outer function, multiplied by the derivative of the intermediate function. Intermediate function is the sine function, and derivative of a sine function is cos into cos of 6x into derivative of the innermost function, which is 6x. So the derivative of 6x is 6. So in the end, our f dash of x is equal to 6 into 3, 18 sine square of 6x into cos of 6x, and it's done.